Hello students, welcome to an important concept and the basic concept in electrostatics, that is Coulomb's law. We know the electrostatics deals with mainly two laws, Coulomb's law and Gauss law. Coulomb's law is an experimental law formulated in 1785 by Charles Augustin de Coulomb. In 1785 he conducted many experiments and he found that there exists some force between the charges. Based upon that finding, he formulated this Coulomb's law. Coulomb's law deals with the force between the charges. In detail, if there exists many point charges, point charge means a small charge, suppose take a pin, in that pin head, if so many charges are aligned, then those charges are called point charges. If there exists many point charges in a medium or in a space, there exists some force between them. One point charge will exert a force on another point charge. This is the Coulomb's law, and we know the charge is measured in coulombs, and 1 coulomb is consisting of 6 into 10 power 18 electrons, and 1 electron carries 1.6 into 10 power minus 19 coulombs of charge. With these basic points, now I will go into the Coulomb's law. Let us go for the statement. It states that force F between two point charges Q1 and Q2 is, first point, along the line joining them, and second point, directly proportional to the product Q1 and Q2, means the product of the two charges, and third one, inversely proportional to square of the distance between them. Okay, so this is a statement of Coulomb's law. So if there are 2 point charges Q1 and Q2, and the force between these two charges is along the line joining them, and directly proportional to the product of the two charges, and inversely proportional to the square of the distance. So mathematically you can write the force F is proportional to Q1 Q2 by R square. Or if you remove this proportionality constant, you can write F is equal to K into Q1 Q2 by R square. What is K? K is a proportionality constant, and that K is equal to 1 by 4 pi epsilon naught. Or you can write it as, and this epsilon naught, permittivity of the free space, epsilon naught is 8.854 into 10 power minus 12 or 10 power minus 9 by 36 pi farad per meter. Okay, these are the constant values. Now we'll see the units. F, you know, it is in newtons, and the charge Q1 and Q2, the charge is in coulombs, and the distance is in meters. Okay, so this is about the Coulomb's law. Fine. Now we'll extend this, and we have a point along the line joining them. Means this first point indicates that S is a vector quantity. This force is a vector quantity because yes, there exists a force between 2 point charges Q1 and Q2. Okay, fine. But what about the direction of the force? Definitely we must know it. For that we are going, or we are extending this concept. Assume that there are 2 point charges Q1 and Q2 like this, and assume that these are located at points whose position vectors are R1 and R2 with respect to the origin. Means imagine an origin. This is the origin. Okay, and this is Q1 and this is Q2, and the position vector is R1, means nothing but the distance between the origin and Q1, that's all, and the position vector is R2. Okay, and now yes, you can go for a distance between the Q1 and Q2, that is called distance vector. So this is the distance vector. F12. Let be R12. Now imagine that the force is on Q2 by Q1. Fine. The force is on Q2 by Q1. Let us represent that force with F12. If I draw the direction, yes, as the force is on Q2 by Q1, this is the direction of F12. If the force is on Q1 by Q2, this is the force direction and that is called F21. Okay, we'll find what is F12. Already we know the F is Q1 Q2 by 4 pi epsilon naught R square. Okay. Now to include that direction concept, here we have taken this diagram and now F12 can be written as, yes, Q1 Q2 by 4 pi epsilon naught R square into AR12. What is this AR12? Unit vector. That unit vector is along R12, that is the distance vector. What is the direction of the distance vector? That is from Q1 to Q2. The force is also in that direction. Okay, yes, you have to check all these directions. R1, R2, the force is on Q2 due to Q1. So you have to find the distance between Q1 and Q2, not Q2 to Q1. Okay, and the direction is like this. Yes, your force is along the line joining them, means this is a line joining the Q1 and Q2. The force is also along this R12. That is the reason the force F12 is written like this. The distance vector R12 is R2 minus R1. Okay, then your distance R is mod R12, that is mod R2 minus R1. And your position vector AR12 is R12 by mod R12, that is R12 by R. Okay, then we'll move to the equation. F12 is equal to Q1 Q2 by 4 pi epsilon naught. What is AR12? Okay, you'll write R square. And your AR12 is R12 by R. Okay, then it becomes Q1 Q2 by 4 pi epsilon naught R cube into R12. Okay, Q1 Q2 by 4 pi epsilon naught. What is R12? R2 minus R1. Okay, by what is R? R is nothing but the magnitude of the distance vector R12, that is mod R2 minus R1. As it is cube, it is mod R2 minus R1 whole cube. Okay, so therefore your F12 totally is Q1 Q2 into R2 minus R1 by 4 pi epsilon naught R2 minus R1 whole. This is totally the force on the charge Q2 by Q1. Okay, again the units are newtons. Suppose if you want to find F21, that is the force on Q1 by Q2. What is the change here? Tell me. The product is same, Q1 Q2 is same, 4 pi epsilon naught is also same. The difference is only the distance vector. The distance vector now is R21, that R21 is R1 minus R2. And if you take the magnitude of R21 and the magnitude of R12 both are same. Am I correct? Okay. Magnitude of R12 and magnitude of R21 both are same. What is this? This is the magnitude. The denominator part is the magnitude. But in the case of F12, numerator consists of R2 minus R1. But in the case of F21, the numerator consists of R1 minus R2. Rest of the terms are same. That is the reason you can write, yes, the first important point is F12 is equal to minus F21. Okay, just the sign is different but the magnitudes are same. R12 is equal to minus R21. Another important point is, suppose if the two charges are similar, like charges will repel each other. Suppose if the charges are like this, plus, plus, there exists a repulsive force. Okay? And if the charges are minus minus, again there exists repulsion. If the charges are like this, yes, what will happen? There exists attraction between them. Another important point that we have to consider to apply this Coulomb's law to find the force between the charges, the distance, this R12, okay, or means the magnitude R, yes, this must be very large compared to the dimensions of the charges. Okay, so R must be large compared to the dimensions of the charges. And this Coulomb's law is the basic law, the fundamental law under electrostatics. You know the electrostatics, it is the field created by the static charges. So as we are dealing with the static charges, remember the charges must be at rest. Charges must be at rest. Okay, now we'll see a special case. What is this case? This is the force between two charges. Suppose if there exists n number of charges like Q1, Q2, Q3, etc., Qn. Okay, then how to find the force exerts by these charges on a charge Q? Yes, then you have to apply superposition theorem. According to the superposition theorem, to find force on a charge Q by n number of charges, just you have to simply sum all the forces exerted by the charges Q1, Q2, etc., Qn on the charge Q. I'll write that. Assume that there are charges like Q1, Q2, Q3, etc., Qn. Okay, and all these charges are exerting force on Q. All these are point charges. Okay, so now how to find? Yes, this is exerting the force on Q and this is also exerting like this. Then the total force on charge Q is F, that is equal to F1 plus F2 plus F3 plus etc. plus Fn. You have to sum the forces, individual forces exerted by all these charges on Q. Okay, so now we'll write F1. What is F1? Tell me. Yes, in our previous concept it is Q1 and Q2. Okay, there Q1 is exerting force on Q2. Here Q1 is exerting force on Q. Okay, simply you can write Q1, the product, 4 pi epsilon naught, there it is R2 minus R1. Okay, here it is R minus R1. Assume that position vector with respect to origin is R. And Q1 position vector with respect to origin, assume that this is the origin, let it be the origin. And the position vector of Q is R and the position vector of Q1 is R1. Okay, so then what is the thing here? R minus R1 by R minus R1. Next, I'll move to the next one. Q, then it is Q2 divided by 4 pi epsilon naught is, assume that your Q2 is at a position vector of R2. Then again R minus R2 by mod R minus R2 whole cube. Yes, if you extend this, Q3 divided by 4 pi epsilon naught, that is R minus R3 divided by R minus R3 whole cube plus and so on. The last one is for the charge Qn by 4 pi epsilon naught r minus Rn by mod r minus Rn whole cube. Okay. So now simply you can write it as the total force F as, yes, in all these terms you can take Q by 4 pi epsilon naught as common. Okay. As this is the summation, I'll take one summation symbol. I'll take a constant K, that is from 1 to n. Then Q1, Q2, Q3, Qn. So you can write it as Qk. Okay. Then R1, R2, R3, etc. Rn. So R minus Rk divided by, again the denominator also you have R1, R2, Rn terms. So mod R minus Rk whole cube. So this is the force exerted on charge Q by n number of charges. Okay. So this is the concept of Coulomb's law. Okay. Extended to this, there is a concept electric field intensity that I will cover in the next class. Thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.